Hello viewers, in today's session we are going to discuss an important problem from integrals, and here we are going to discuss this problem where we are given a function f which is from r to r, where r is the set of real numbers such that f of x is equal to the integral 0 to x t square f of t dt plus x cube. And if this function f of x is differentiable for all x belonging to the set of real numbers, then we have to find f of x, right? So here we will apply the Leibniz integral rule to find f of x. So let us start. So here we are given f of x is equal to the integral 0 to x t square f of t and dt plus x cube. Now let us differentiate both sides with respect to x. So we have d by dx of f of x, and here we have d by dx of this integral 0 to x t square f of t dt, and then we have to differentiate x cube with respect to x. So we are given the function f of x in this form, and let us differentiate both sides with respect to x. So here d by dx of f of x is f prime of x, and here we have the derivative of x cube as 3x square. Right now, to differentiate this integral with respect to x, will make use of Leibniz integral rule. Right now, see, if we have a function, say f of x is equal to the integral, say a to x, and here we have a function, say g of t dt, then the derivative of f of x, that is f prime of x, is equal to simply g of x, that is we replace this t by x, right? So here we have this integral, right? And if we compare this integral with this one, then the value of a is 0, and here we have x, here also we have x, and for g of t we have t square f of t. So the derivative of capital F of x, that is f prime of x, is simply equal to g of x. So here, applying this rule to this integral, we have simply or we have to simply replace all these t's by x. So we have now x square, and here we have f of x. So now we have the expression for the derivative of f of x as f prime of x is equal to x square, and here we have f of x plus 3x square, right? So now we have a differential equation, and we have to solve this differential equation. So what we will do, we'll write f prime of x, we can take x square common, so we have f of x plus 3, right? Okay, so now we can write here separating the variables. Here we can write f prime of x divided by f of x plus 3, and here we have x square. Now let us integrate both sides. So we have integral f prime of x dx, and here we have f of x plus 3, and here we have integral x square dx, and c is the constant of integration. So now to find the integral of this entire integrand, we can make use of the method of substitution. So let us take a u is equal to f of x plus 3. Now a du over dx is equal to f prime of x. So differentiating both sides with respect to x, du over dx is equal to df over dx, that is f prime of x, and the derivative of 3 being a constant is 0. So we can now write du is equal to f prime of x and dx. So now for f prime of x dx, we can write du, and for f of x plus 3, we can write simply a u. So we have the integral du over u, and here the integral of x square is x cube over 3, and c is the constant of integration. So here we have applied this rule, that is integral x raised to n dx is equal to x raised to n plus 1 over n plus 1, provided n is not equal to minus 1. So now we have integral du over u, and the integral of 1 over u with respect to u is the natural log of u, and here we have x cube over 3 plus c. Now let us replace this u by f of x plus 3. So we have natural log of f of x plus 3, and here we have x cube over 3 plus c. So now we need to find out the value of this constant of integration c by using some initial condition. So now let us take x is equal to 0 in this equation. So we have f of 0, and then we have 0 to 0, and here we have t square f of t dt, and x cube is 0 cube. Now f of 0 is equal to 0 plus 0, because here the limits of integration, both the limits of integration are 0, so the value of this integral is 0. Here we have 0, so we have 0. So when x is equal to 0, that is f of 0 is equal to 0. So let us apply this condition to get the value of c. So let us take x is equal to 0 in this equation. So we have now natural log of f of 0 plus 3, and here we have 0 cube over 3 plus c. Now this is natural log of f of 0 is 0. So here we have 0 plus 3, and this term is 0, and here we have c. So natural log of 3 is equal to c. So the value of the constant of integration c is equal to a natural log of 3. So now let us substitute this value of c in this equation. So we have log of f of x plus 3 is equal to x cube over 3 plus a natural log of 3, right? Now taking natural log of 3 to the left hand side, we have natural log of f of x plus 3 minus natural log of 3 is equal to x cube over 3. Now applying the properties of natural log, we have here a log of f of x plus 3 divided by 3, and here we have x cube over 3. So here we have applied this rule, that is natural log of a minus natural log of b is equal to natural log of a over b. So using the properties of logarithms, we have now this expression. So now natural log of f of x plus 3 over 3 is equal to x cube over 3. So now removing this natural log, we can now write f of x plus 3 over 3 is equal to e raised to x cube over 3. right? And multiplying this term by 3, we have f of x plus 3 is equal to 3 times e raised to x cube over 3. And now we can take this 3 to the right hand side. We have 3 times e raised to x cube over 3 minus 3. And taking 3 common, we can now write 3 times e raised to x cube over 3 minus 1. So this is the required expression for f of x.